Okay, good day. This is AP Calculus Summer Review. I am Mr. McCully. This is SR number 5, completing the square. We are almost halfway done here, folks, so let's get right to it. Today we're going to be talking about completing the square, and we're going to be talking about completing the square to solve quadratic equations. We're going to talk about completing the square to find vertex form of a quadratic function, and we will complete the square to find the simple equation of a circle or an ellipse. Okay, so first off, what are we doing here? Completing a square you have seen since Algebra 2, and we've used it in a number of different processes before we got to AP Calculus. We've used it to solve quadratic equations, find the vertex form of a quadratic function, and convert from the general form of a conic section. This is what we did pretty much one of the last things we did in pre-calculus. But in calculus, we will be using completing the square for different processes, but we need to do a little bit before we get there. So I thought we would review the process that we've learned so far. So completing the square. From application to application, the process is going to vary a little bit, but in all instances, we are going to be very interested with this coefficient in front of the squared term and the coefficient in front of the linear term. This constant isn't going to be that big of a deal. In almost every instance, in fact, in every instance that I know of, we are going to make sure that we manipulate this function. The first thing that we're going to do is to manipulate the function so that the a coefficient is always 1. And once that has been completed, we are going to add in some way half of b squared so that we can have now a perfect square binomial. Now this constant doesn't go away, this c doesn't go away, but we're going to move it out of the way so that we can use this as a new constant of some sort. So kind of a little review of a visual representation. I'm sure you've seen me do this before, but let's say I have x squared plus 4x, and I want to complete the square. Well, what does that mean? Well, if I think of this length here as x, as the distance x, and I think of this distance as 1 unit, well, if I copy this, or if I were to change this and go, let's see here, copy, oh, I want to clone it, there we go, and I think I want to clone it once more, and so let's put this one right here, and then we will change this to a vertical line. It looks about the same, my pen. So right here, we have an x by x, so this thing, I don't want the arrow, I want one like this. So this area right here represents x squared. It's x squared. Well, I've got 4x. Well, if I take x times 1 and I create a, let's see here, a rectangle. Yeah. And I make a rectangle that is this long by, well, let's say 1 unit wide, this length right here wide. Well, this rectangle here that I have created, and maybe I can move, is 1 by x. So x times 1, this has an area of 1x. Well, I need 4 of these things. So let's make 4 of these things. And we'll clone this once. We'll clone it twice, and we'll clone it 3 times. So these things here, these 4 rectangles represent an area of 4x. Well, we want to complete the square, so we want it to continue to be a square. So let's move this down just a little bit. Maybe I can move it down just a little bit. And what I'm going to do is I'm going to line these up evenly so that I get a square shape. So let's put this one right there. And let's put the second one right here, like that. And then just to make it get close to square shape, there we go. I'm going to put this one right here, and obviously my square is a little wider than it is tall, like that. And just so I don't have to do that, we will cut this out and we'll clone this one. That way we can make it work. Okay, that looks pretty good. All right, so we have this expression, this graphical representation of this algebra expression. We have x squared plus 1, 2, 3, 4 x's. Now what we want to do is we want to complete this square. Well, that's not too bad. We're going to draw some lines here, and there, those aren't very good. Let's see if we can make them look a little bit nicer. There we go. There we go. But we are adding this. This amount right here is not, this green area is not part of this. Well, how much is it? Well, let's think about it in terms of what we've created. This length is 1, this length is 1, this length is 1, and this length is 1. So each of these areas, 1 times 1 is 1, and so I have added 4 to this expression. That's what I'm adding with the green. When I look at this, look what I have. This distance here is x plus 2, and this distance here is also x plus 2. So what I have done is I now have, if I say this is x plus 2, this is x plus 2, this graphical representation says that this thing is the quantity x plus 2 squared. And that is essentially what completing the square is. Now this one had an a value that was 1, but notice, how do I get that 1/2 b squared? Well, if you look at b, it's 4. I took those 4 x's and I divided them into 2. I put half of them on this side and half of them on that side. And that numerical value, 2 times 2, gives me that 4. So that's that half of b squared to get the constant. So hopefully that sheds a little bit of light on it. Let's get right to the practice problem so we can get this done. So use completing the square to solve. So we want to solve this expression, and one of the reasons that completing the square is good for something like this is, if you notice, I have an x squared and a linear x to the first. That's kind of hard to separate and get it so that you can find out exactly what x is when you have variables of different powers. So if I can complete the square and take it from an x squared and an x just down to an x, that's pretty good. So let's see what we got here. So the first thing I want to do is move the constant. And when I move the constant, it's added here, so I'm going to subtract. So I'm going to go 2x squared minus 8x, and then we're going to subtract, let's see here, we'll subtract 6. Okay, make it minus. There we go. I've subtracted 6. Now, I have to divide by a so that I get just x squared, so that the coefficient in front of the x squared is just 1. So I'm going to divide everything by 2, and because I'm doing it to all the sides, I haven't changed the function, so I get x squared minus 4x equals -3. And then I'm going to add 1/2 of b squared to both sides. And so half of b, so b is -4, half of that is -2, so I'm going to add -2 squared to both sides, and let's rewrite that, make it look a little nicer. And so this is now the perfect square binomial x minus 2 quantity squared. I have -3, and -2 squared is +4, -2 and 4 is 1. I'm going to take the square root. And remember that when you take the square root, you have to add your plus or minus. So square root both sides gives me x minus 2 equals plus or minus the square root of 1, which is just plus or minus 1. And I add 2 to both sides, so I got x equals 2 plus or minus 1, and we shouldn't leave that because this 1 is an integer and we have like terms. So x or 2 plus 1 is 3 and 2 minus 1 is 1. So my solution by completing the square is 3 and 1. Okay. Next one, use completing square to convert the following to vertex form. So this is a quadratic function, and we want to get it into vertex form so we can find the vertex, which is at hk. All right. Now this one's a little bit different because it has a y and an x in it, and we want all of the values other than y by itself on the right hand side. We're going to work solely on the right hand side. So since I'm going to, again, I'm going to have to add that 1/2 b squared. Remember, whatever I add, I have to take it away so that I am not changing the function. So first thing we're going to do is we are going to group the 2x squared plus the 12x, and we're going to give us some space and we'll move that constant kind of out of the way so that we can deal with it later. So I'm going to go y equals 2x squared plus 12x, and then plus that 22. And so first thing I want to do is I'm going to group those first two terms. Now, again, we got to change the a value so that it is x squared. That's what we want to do. So what I'm going to do is, since I've grouped it, I'm going to factor out this 2, and when I divide 2x squared by 2, I get just x squared. And when I divide the 12x by 2, I get 6x, still leaving some space because I'm still going to complete the square, plus the 22 that I had. Now, when I look at this, I'm going to add and subtract. So that, again, I'm adding and subtract half of b squared. 1/2 of b squared. Well, if I look at my b value, I'm going to, the half of 6 is 3. I'm going to add that squared. And since I've added it, and I can't do it to both sides because, again, I want to leave my y by itself. I can't do it to both sides, so if I'm adding something, I have to subtract it away. Now the thing is that I've put it inside the parentheses here. So it's still affected by, I have to distribute this 2 to all of those terms. So it's not just adding 3 squared, I'm adding 2 times 3 squared. And since I'm adding 2 times 3 squared, I must also subtract away 2 times 3 squared. Now again, this is now a perfect square. It's y equals 2 times x plus 3 quantity squared. And then I'm going to simplify these constants. So 3 squared is 9. 9 times 2 is 18. 22 minus 18 is 4. And this is our final answer based on the question that they asked. This is vertex form. So if I wanted to read the vertex, it would be, again, you notice it's minus h, and so since I have plus 3, it's going to be negative 3, and since it's plus k, it's just going to be positive 4. And that's the vertex, if you were ever asked to do that. Hint, hint. But that's it. Okay, moving on. Use completing the square to find the center and radius of a circle. So we're going to do something similar. And the first thing I want to do is I want to collect my like variables. Now you've heard collect your like terms, but I want to get when I say collect my like variables, I want to get my x's and my y's together. So I'm going to go x squared minus 6x, and then I'm going to leave a space to complete the square. And then I'm going to go y squared plus 4y. Again, leave some space to complete the square and move the constant to the other side, leaving me with just 1. So now, and again, I'm going to need some space here. I want to, since the a coefficient for the x squared and the y squared is both 1, I don't have to do anything else, which is awesome. And so what we want to do is we want to complete the square. So we're going to go, let's see here, it's going to be plus negative 3 squared, that's half of that b, plus half of 4 is 2 squared. And again, because I'm not necessarily saying that I have to, because I got values on the left and the right in my final answer. I don't have to add and take away. I'm just going to add to both sides. I'm going to add, let's see here, negative 3 squared, and 2 squared. And so this is now the perfect square binomial x minus 3. And this is now the perfect square binomial y plus 2. And then let's see here, 1 plus 9 is 10, plus 2 is 14. And this is the center and radius formula. I need a square here, sorry, of that circle. And if I wanted to, I could say the center. And remember, it's minus on both of these this time, so that would be at 3, -2, and my radius. This expression, this 14, is r squared, so the square root of 14 is going to be my radius, square root of 14. I know that doesn't come out nice, but there you go. All right. Okay, last one. Not doing too bad here. I'm going to use completing the square to find the standard form of the ellipse. Well, this is ugly looking. And if you remember, the standard form of the ellipse is going to be x. Let's see here. X minus h squared over a squared plus y minus plus y minus k quantity squared over b squared equals 1. That's what we eventually want to get to. All right, so we're going to do something similar to what we did the last time. So I'm going to collect my variables, my like variables. And let's see what we have here. So I'm going to have my 16x squared, and I'm going to go minus 64x. And then let's see, I've got to leave a little space to complete the square. And so I've got 25 plus 25y squared plus 150y. And then I'm going to have some space. I'm going to move my constant over, and that'll be positive 111. Okay, awesome so far. So now I want to factor so that I can get x squared and y squared. So I want to factor out so that I can get just 1x squared and 1y squared. So I got to factor out a 16. So I'm going to go 16. And when I divide 16x squared by 16, I get just x squared. And when I divide 64 by 16, I get just -4x. And when I factor out 25 divided, I wrote 20. Sorry guys, I'll get this. I didn't want that either. So let's make it small or medium. Okay. 25, and then I've got my y squared, and when I divide 150 by y, or 150 by 25, I get 6y. We want that to equal 111. Okay, that's good. So now I want to complete the square. All right, so let's see here. I'm going to have to add, let's see here, 14. So I've got, let's go 16. Let's see, 16. I got x squared minus 4x. Half of that -4 is -2, so I'm going to add -2 squared. And then I'm going to go 25. I got my y squared plus, and then I've got my 6y, and then half of that b is 3 squared. I got 111 here. Okay, not too bad so far. Looks good. And but now again, I've added something on the left hand side, so I also have to add it on the right hand side. I'm not adding just this -2 squared. I'm adding 16 times the -2. So 16 times -2, and I'm just going to move this over, or else it would be difficult to squeeze it in. Squared plus, and I didn't add just 3 squared. I added 25 plus 3 squared. So 25 plus 3 squared. Okay, so this becomes 16, and I have, let's see here, x minus 2 quantity squared, and this one becomes 25 times y plus 3 quantity squared, And that's going to equal, well, let's see here. 2 times 16 is 4. 4 times 16 is 64. 3 squared is, let's see here. So we got, let's see here. 111 plus 64 plus 3 squared is 9, and it's 225. And so 111 and 64, I add 1, so I got 174 and, or no, 175 and 225 is 400. So this is 16x minus 2 quantity squared plus 25 times y plus 3 quantity squared equals 400. We're real close. We're real close here, folks. I got to have that 1 there. So what we want to do is we're going to divide both sides by, and whatever number you get here, that's what you're going to divide by. So divide by 400, divide by 400, divide by 400. This cancels out and gives you just 1. 25 goes into 400 16 times. So I've got y plus 3 over 16. And then 16 goes into 400 25 times. So I've got x minus 2 squared over 25, and that is my final equation. All right, folks, that brings us to the end. And as always, if you have any questions or if you feel that I've made an algebra error somewhere, please feel free to either email me at the address I gave you at the beginning of the year or at the end of the year, and you can also leave a comment in the comments section below. As we finish up, let's talk about our Super Star Wars fun fact of the day. Bespin in Empire Strikes Back. Bespin is the name of Lando Calrissian's planet, and it is actually a gas giant that they are harvesting specialized gases for unsavory characters. Well, that's it there, folks. That's all I've got. 22 minutes isn't too bad for something that's that big and fairly challenging. Hope you're having a good summer, and I will see you next time. Goodbye.